Question 11, Part E. Solve 3 over 2x plus 5 minus x greater than 0. Starting with the inequality 3 over 2x plus 5 minus x greater than 0, I've rewritten the inequality so they've got something on the left-hand side and something other than 0 on the right-hand side. So I have 3 over 2x plus 5 greater than x. Looking at the denominator on the left-hand side, now we can't have division by 0. So 2x plus 5 cannot equal 0, which implies that x cannot equal negative 5 over 2. Now we can find other critical points by solving as an equation 3 over 2x plus 5 equals x. So I've replaced the inequality symbol with an equal sign. Note that it's greater than, not greater than or equal to. So whatever critical points we find by solving this equation, x cannot equal those critical point values. So multiplying both sides of the equation by the denominator 2x plus 5, we get 3 is equal to x outside of 2x plus 5 in brackets. And expanding the right-hand side, we get 3 is equal to 2x squared plus 5x, which gives us the non-monic quadratic equation 2x squared plus 5x minus 3 equals 0. Factorizing the left-hand side, we get 2x minus 1 in brackets times x plus 3 in brackets equals 0, which implies that x cannot equal negative 3 or x cannot equal 1 over 2. Now the final step is to test around the critical points using the original inequality. So that's this inequality here. And just testing that the left-hand side is greater than 0. Or in other words, the left-hand side is positive. So on the incomplete number line here, I've shown the critical points using open circles since x cannot equal negative 3, negative 5 over 2, nor 1 over 2. So I've chosen values around these critical points. I've chosen negative 4, which is to the left of negative 3. I've chosen a value in between negative 3 and negative 5 over 2, which is negative 2.5, and I've chosen negative 2.75. Now, a convenient value between negative 5 over 2 and 1 over 2, of course, is 0. And a value to the right of 1 over 2 is 1. So substituting those values into the original inequality, we end up with these values. We get 3, negative 3.25, positive 0.6, and negative 0.57. So the inequality is true here, it's false here, it's true here, and it's false here. So completing the number line by joining the circles where needed, and also drawing an arrow in the correct direction from one of the other open circles, we have an arrow from negative 3 pointing to the left-hand side, and we're joining these two open circles, so between negative 5 over 2 and 1 over 2. So writing our solution, we get therefore x is less than negative 3, or x is greater than negative 5 over 2 and less than 1 over 2. And expressing that solution in interval notation, we get this expression here.